structure of the carbonyl group. Structure of carbonyl group present in aldehydes, ketones and acids. Okay. Carbonyl group. Here this carbon is sp2 hybridized and this carbon contains 3 sigma bonds. And the 4th electron will present in the p orbital. This p orbital will overlap with the p orbital of the oxygen atom and form one pi bond. Okay. Next, this pi bond will be present above and below the plane of the molecule like this. Okay, will be placed above and below the plane of the molecule, and this carbon atom is sp2 hybridized. This sp2 hybridized orbital will overlap with the another orbital and form sigma bond. Here also same will be the case. Now next, what will be the structure? First we have to find the angle. Angle will be 120 degree each. Okay. The bond angle will be 120 degree each. So, the structure of the compound is trigonal coplanar. Compound is trigonal coplanar. Okay. Next, polarity. Polarity. Carbon, oxygen. Okay. Here this oxygen is highly electronegative. So the shared pair of electrons will move towards this oxygen, and oxygen is partially electronegative and carbon is electropositive. So this carbon is electrophilic center or Lewis acid. Okay. And oxygen is nucleophilic center or Lewis base. Okay. As a result of this polarity, this is having a dipole moment. Okay. Dipole moment. And polarity is greater than or more than ethers. Okay. This is having high polar due to the resonance stabilized, because there are two structures possible, one neutral structure and this polar structure. So this is having highly polar. Okay. Next, preparation of aldehydes and ketones. There are certain methods for the preparation of both aldehydes and ketones. We can use the same method for the preparation of both aldehydes and ketones from alcohols. First case, from alcohols. From alcohols. Primary alcohols on oxidation gives aldehydes. Similarly, secondary alcohol gives ketones. Okay. And the reducing agents used here are acidified KMNO4, potassium permanganate. Okay. Or acidified K2Cr2O7, potassium dichromate. We can use any of these reducing agents for the oxidation of alcohols. Okay. First, CH3CH2OH. This is ethanol. Ethanol on oxidation. Okay. In presence of acidified KMNO4. Okay. This gets converted into CH3CHO. Okay. Ethanol will be obtained. Okay. Ethanol. Next, plus H2. Next, secondary alcohol, CH3, CHOH, CH2, secondary alcohol. This is 2-propanol. Okay. 2-propanol on oxidation gives same reducing agent is used, and the product obtained will be CH3CO, CH3 acetone will be obtained. Okay. This is the first method. Preparation of aldehydes and ketones. Here the yield of aldehydes are very less. aldehydes produced are very less, because as soon as the ethanol is produced, that will get oxidized and form acid. So what we have to do? By distillation, we have to, as soon as the ethanol is obtained, by distillation we have to remove the ethanol from the reaction mixture. Okay, so then only we will get the good yield of aldehyde. Okay, next case, by catalytic hydrogenation, catalytic dehydrogenation of alcohols. Okay, second case, catalytic dehydrogenation of alcohols. Second case. Okay, here the catalyst used is copper, heated at about 573 Kelvin. The ethanol, primary alcohol gives aldehydes, and secondary alcohols gives these ketones. Okay, so CH3, CH2, OH, ethanol on reaction in the presence of dehydrogenation in the presence of copper at a temperature of 573 Kelvin. The product obtained will be CH3CHO plus H2. Okay. Next, CH3 CHOH, secondary. Okay, same reaction gets converted into CH3 COCH3 plus H2. So dehydrogenation takes place and form aldehydes and ketones. Now, next third process from hydrocarbons. Okay, from hydrocarbons like alkenes and alkynes. Okay, third case from hydrocarbons. First, from alkenes. How can we obtain? From alkenes react with ozone, O3, and form ozonide. This on decomposition with water in presence of zinc dust, it gets converted into aldehyde. Let us take this. CH3, CH double bond CH2. Propene on oxidation, what will happen? Okay. CH2. Ozonide will be obtained. Okay. Next, this on decomposition with water and zinc dust. What will happen? Break will be here. So, the product obtained will be CH3CHO plus HCHO, okay, plus H2O and oxygen. So, H2O2. This will be the reaction. Okay. Now, how can we obtain a ketone? Ketone can be obtained from another compound, C double bond C, CH3. Dimethyl butene will be the reactant. On reaction with ozone, what will happen? Oxygen. Okay. Ozonide will be obtained. CH3, CH3, CH3. Again, same reaction, hydrolysis. It's zinc dust. Okay. 2 molecules of CH3, COCH3 plus H2O2. Okay. This will be the reaction. Now, next hydrocarbon is alkyne. From alkynes, how can we obtain? On reaction with 40% sulfuric acid and 1% mercuric sulfate. Okay. Alkynes. How can we obtain? CH triple bond CH, ethyne. Okay. Hydrolysis. Okay. Hydrolysis takes place. Presence of 40% H2SO4 and 1% HgSO4. The reaction takes place. Okay. First, vinyl alcohol will be obtained. Vinyl alcohol, okay, OH, vinyl alcohol, okay. This rearranges and give CH3CHO, okay. Acetaldehyde will be obtained. Like this, aldehyde can be obtained from alkynes. Next, propyne, CH3, CH, triple bond CH, C triple bond CH. Propyne. Same hydrolysis takes place. Presence of 40% H2SO4, 1% HgSO4. Okay, CH2, CH3 double CHOH, secondary alcohol, CH2. Okay, this will be obtained, then rearranges and form CH3, COCH3. That is, ketone will be obtained. Like this, alkyne can from propyne we can obtain ketone. These are the different preparation methods of aldehydes and ketones.